Hey everyone, and welcome to today's Explainer. I am so thrilled to have you here. Today, we're going to look at something you probably rely on literally every single day, but honestly, you probably rarely think about it. Yep, we're talking about that little blinking box sitting quietly in the corner of your room or office, the router. We're going to completely demystify this thing. By the time we're done here, you're going to see the router not just as some random piece of plastic that magically gives you Wi-Fi, but as the absolute unsung hero of our daily digital lives. It's a complex traffic director and really the vital frontline defense for your entire network. Okay, let's dive into this. Here is our roadmap for today. We'll start with router basics and functions, then check out the main router components. After that, we'll hit the routing and traffic process, followed by NAT and DHCP services. Then, we'll get into router security and attacks, and wrap the whole thing up with what to learn next.
All right, part 1, router basics and functions. Let's kick things off right at the beginning.
Think about the mobile phone in your pocket right now. Chances are it's connected to Wi-Fi, right? But how does tapping a link on that screen actually pull up a website from a server that's maybe thousands of miles away? Well, that is exactly where a router comes in. By definition, it's a network device that connects different networks together and makes sure your data actually reaches the right destination. Think of it like a bridge. It's the literal bridge between your phone and the massive expanse of the internet. You ask for a website, the router takes your data packets, ships them out across the internet, grabs the response, and carries it right back over that bridge to you. To pull all of that off, the router has a pretty heavy list of daily chores. It connects networks, it's constantly calculating and selecting the absolute best path for your data to travel, it forwards that traffic, it performs NAT, it provides DHCP services. Don't worry, we're going to break both of those acronyms down in a minute, and it even serves as your network's basic firewall protection. So yeah, it is a seriously busy machine. Moving right along to section 2, main router components. Let's conceptually pop the hood and see what's inside. You know, you might be surprised to find out that a router is essentially just a highly specialized computer. Just like your laptop, it's got a CPU, which is the brain of the whole operation, making all the logical decisions. It uses RAM as temporary memory to juggle the data it's currently working on. It's got ROM for boot instructions and flash memory, which permanently stores its operating system. And finally, the physical interfaces, or ports. You've got LAN ports for your local stuff, a WAN port connecting to the wider internet, and a console port for direct, hands-on management. That brings us to section 3, routing and traffic process. Hardware is cool, but how does the software work? How does the brain actually handle the crazy volume of data flying through it every single second? Let's track one single data packet. The millisecond a packet shows up, a rapid-fire 4-step process kicks into gear. First, the router checks the destination IP address, basically asking, where are you trying to go? Second, it consults its internal map, which we call the routing table. Third, it picks the best possible route. And fourth, it forwards that packet right out the correct interface toward its next stop. And this brilliantly illustrates how that decision gets made. The routing table is basically a simple database of networks and directions. If a packet is looking for the 192.168.1.0 network, the table says, hey, that's directly connected, send it on through. But if it wants the 10.0.0.0 network, the table tells the router, okay, send this to the next hop at 192.168.1.1. It's just perfectly organized traffic direction. Now, you might be wondering, how do those routes actually get into the table? Well, you've got two main options. Static routing is the manual way. An admin literally types the routes in. It's super simple and highly secure, but man, it is a nightmare to maintain if your network gets huge. That is exactly why dynamic routing exists. This is where routers automatically talk to each other and exchange route info using smart protocols like RIP, OSPF, EIGRP, or BGP. It's totally automated and scales up beautifully. Okay, on to section 4, NAT and DHCP services. Let's look at the broader services your router provides. We mentioned these earlier, and they are totally the unsung heroes of your network. First up, Network Address Translation, or NAT. This solves a huge problem. See, your local devices, like your laptop, have private IP addresses, something like 192.168.1.10. But the internet, it cannot route to a private IP. No way. So when your laptop wants to surf the web, NAT jumps in and translates that private IP into a public IP, like 39.x.x.x. It completely masks your internal network from the outside world while letting you browse the internet seamlessly. Pretty clever, right? But wait, how did your laptop even get that private IP in the first place? That is the magic of DHCP.
It automatically hands out IP addresses the second a device connects. It uses this really slick four-step process, and you can actually remember it with the acronym DORA. First, your device sends out a discover message. Then, the router sends back an offer. Your device shoots back a request for that specific IP, and finally, the router finishes it off with an acknowledge. Bam, just like that, you are officially on the network. So we've covered all the amazing heavy lifting a router does to keep us connected, but all this connectivity brings up a really serious, high-stakes question. Think about your own router for a second. Is it actually secure?
Which brings us right to Section 5, Router Security and Attacks. This is absolutely crucial stuff. Because the router sits right at the very edge of your network, facing the wild west of the internet, it is a massive target for bad actors. And attackers are constantly probing for common vulnerabilities. They love finding routers where the default admin passwords were never changed. They scan for outdated firmware that has known exploitable bugs. They'll try to brute force weak Wi-Fi passwords. They actively look for sloppy, misconfigured remote management settings. And they especially hunt for unsecured telnet access, because telnet sends your data completely unencrypted. Yikes! So you have got to harden your attack surface. How do we do that? Well, first off, use strong, unique passwords across the board. Ditch Telnet completely and use the encrypted SSH protocol instead. Be religious about keeping your router's firmware updated to patch those bugs. Turn off any unused services. If you don't need it, don't run it. And absolutely always make sure your built-in firewall is actually turned on to block all that weird, unauthorized traffic. And as we talk about these vulnerabilities, I want you to keep this mindset from our source material front and center. Your focus must be to identify and secure these weaknesses, not to gain unauthorized access. Knowing how the bad guys operate is simply a tool so you can build stronger, better defenses on your own network. All right, final section, what to learn next, because we really are just getting started. We've covered a ton of ground today, from the physical hardware to dynamic routing and vital security. But if you want to become a master in this field, the source material lays out an awesome path forward. You can dive into the math behind IPv4 and IPv6 subnetting. You can learn how dynamic protocols like OSPF and BGP literally keep the global internet running. You can figure out how to write access control lists, configure VPNs, manage quality of service, and get really deep into advanced router hardening. There is so much more to explore. Look, every network out there, from a tiny coffee shop to a massive enterprise, relies on these exact concepts. Your router isn't just a bridge. It is literally your network's frontline defense. Understanding how it works gives you the power to actually control and protect your digital footprint. So armed with all this new knowledge about the hardware, the routing tables, and the security threats, are you ready to secure it? Thank you so much for hanging out with me for this explainer. Keep learning, and I'll see you next time.